Sorry, Maggie. All right, so, but I've got two angles and a side. So if I have two angles and a side, I don't have to worry about any special cases here. I'm just going to set this up and solve. Okay, so to set it up, I'm going to take an angle. So I'm going to take it 37 just because I want to use 37 first. And I'm going to say sine of 37 over the side across from 37, which is 3, equals, and now I got to use the other angle that I know, sine of 68 over side B. Okay. Oh, sorry, didn't mean to make that disappear. Trying to make room for my calculator. All right. So, to solve this proportion, you can cross multiply, right? Because if two fractions are equal to each other, you can cross multiply. So I will get B times sine 37 equals 3 times sine 68. It doesn't matter which side of the equal sign you put those two expressions on, but I like to have the B on the left-hand side, so I put it that way. Now, I am trying to solve for B. That's what I want to know. What should I do with that sine 37? Divide, because it's just a number, right? So I'm going to divide by sine 37 on both sides. Okay? If I'm going to type that in, you're going to do 3 sine 68. I would hit enter there. And then divide by sine of 37. It'll help you avoid errors if you forget a parentheses there. And we're going to get 4.622 if we round to 3 places. Yes. So that is side B. Now all it asks us to do here is find side B, so we're done. Right. If we wanted to, we could use that information to find other parts of the triangle, but it didn't ask us to do that. It just asked us to find B. And that's it for a problem like this. So set up, cross multiply, solve for your variable that you're missing. Okay. If you have two angles, it is not a special case. So you just set it up and solve. Any questions here? All right. Okay. For this triangle, we've got P, Q, R. P is 28, Q is 22. Measure of angle P is 120, and we're supposed to find the measure of angle R. So I'm going to draw out a picture for this. I know angle P is 120, so I want to make it an obtuse angle to try to be a little bit to scale, but it may not be perfect there. So P is 120, and then I know side P is 28, so that'd be the side across from P. Q is 22, so I'm going to put my 22 here. If I put 22 here, then this is vertex Q. And then the other one is R. I don't know anything about R. All right, so if I look at the information I have here, I have this side, and the angle. Is that angle, the 120, between the two sides that I know? It is not. Because if you do have the angle in between, if the angle was right here, if it was angle R, then it would be angle, side, angle. We actually would have to use law of cosines. That's what we'd have to do tomorrow, so you're not going to see anything that's angle, side, angle. We can't solve it yet. But if I had angle, side, angle, I would not have to check for anything special. But I do not have angle, side, angle. I have angle, side, side. Watch out. Okay? Be careful. So that, you know, I kind of, you know, I like to write this on my paper, not for the shock value of it, maybe a little bit for the shock value of it, but because as soon as you're writing those 3 letters, unless you're accustomed to writing this word a lot, something should be going off in your brain like, this is not right, this is not right, this is not right. And that's what I want to happen here, because you've got to watch out for something special here, okay? If you have angle side side, it means there's possibility for 2 different triangles. We call it the ambiguous case, meaning we're not quite sure, right? Because it could be one thing or another. So we got to watch out for that. I'm going to show you how to check for that here in a minute, okay? It doesn't mean it definitely is ambiguous case. It just means it could be ambiguous case. So what we're going to do is we're going to set the problem up like we would for any problem, okay? Now, it asked me for measure of angle R right here. Do I know the side across from angle R? I do not. Can I find angle R right now? I cannot. Because if I set it up, it would look like this. Don't write this down because this is wrong. It'd look like sine R over lowercase r equals sine 120 over 28. Can I solve when I have 2 variables? I cannot. So I cannot find R. What's the only thing I can find here? I could find Q, right? If I find Q, can I then find R? I can find it pretty easily because all the angles of a triangle add up to 180 degrees. So I can just do 180 minus 120 minus whatever we get for our Q. So I'm actually going to have to find Q first for this. Q is what I'm going to have to look for first. Then I can find R. So I'm going to say sine of Q over the side across from Q, which is 22. And this one's going to be a little bit different because we're not solving for a side, we're solving for an angle this time. So we're still going to cross multiply. So I will get 28 sine of Q equals 22 sine of 120. And this Q right here is what I'm solving for. Now this is different than the last problem. Last problem I just like divided off my sine 28 or whatever I had there and we got our answer. I can't divide off 28 sine without doing something with that Q. What can I divide? Just the 28. Okay? So that sine is still there. Sine of Q is going to equal, I can type this into the calculator. So 22 sine of 120. I would suggest hitting the enter button here just to make sure you don't forget a parentheses. Divided by 28 is going to give us 0.68048. Okay, then we can do sine inverse. Okay, so Q is going to equal, whenever you do this, you can either store that value as a letter, or you can do it this way. You're going to do sine inverse of, you can, if you have the fancier calculators, you can just go up there and hit enter, and that'll be better, or that'll be easiest. But if you've got an older one of these calculators that doesn't let you do that, you do second negative, it'll use the answer from the line before, or you could store it. But don't round it. All right, so if you store, sine of 120 divided by 28, because I already hit it. All right, so you've got this value right here. To store, you're going to hit this STO button right above your own. And then alpha, whatever letter, so like if you want to call it A, right there, you would do that. And then so you could do sine inverse of A. Or as long as it's the line before, you can just do second negative, which is going to take the answer from the line before. So either of those will work, but try not to round that because it will throw your answer off.
You always just like type it in.
You can. If you store, it's going to keep even more decimal places than you see right there, and you don't run the risk of accidentally typing one of the numbers in wrong. So it's better to use either store it or use the line, above. Just because if you type in 0.6844 and leave that 0 out, it's going to throw you off by quite a bit. So it's better to store, but you can just type it in.
So in that, since it is a triangle, are we going to round to the nearest whole number, or are we going to do that?
We'll keep 3 decimal places here. So 42.879. All right. So even if you have angle side side, you're going to do all this the same at the beginning. All right. Now, angle side side, this is where we have to check. So once you find that angle, all right, we must check for ambiguous case. Now, I'm not going to go into great detail about it because you guys don't know much, if anything, about the unit circle yet. But the calculator is giving us what we call principal values, which means that it's giving us the most common answer that you would have whenever you're solving this. But the way trig works, and when we learn about the unit circle, you'll understand why a little bit better. But there's actually an infinite number of answers to this. Now, for a triangle, it can only be a maximum of 2 because your angles can't be over 180 for a triangle. But trig values start to repeat themselves after 90 degrees. So it's possible that there's actually another answer that would work here. So to check for ambiguous case, we're going to subtract the angle from 180 degrees and see if it would also work as angle Q. Alright, so when you find the angle, if it is an angle side-side problem, you are going to do 180 degrees minus that number that we just got. I'm going to put Q question mark here because we're not sure if this could be Q or not. So if we take 180 and we subtract that number that we just had, we get 137.121. degrees. So I know for sure 42.879 works. If I look over here and say that angle Q is 137.121 in this triangle, does that work? No, why not? It adds up to be more than 180, right? It's too big. It cannot work. So this is a no. That does not work. So this is not ambiguous case. Only one answer. Right? So even though there was potential for it to be an ambiguous case, for there to be actually 2 triangles that would work here, it's not. It's just one answer. The only thing you can have for Q is 42.879. So now that's not my answer because it wasn't asking me for Q. What did it ask me for? R. So I do need to find R. So I know Q is 42.879. I'll do 180 minus the 120 minus the 42.879 .79. This will give me the measure of angle R. If you ever see that M before the angle R, that means measure of angle R. That's our standard notation for that. So 180 minus our 120 minus that 42.87870283. We will get 17.121. And that would be our answer for measure of angle R. Okay. So, let's look at this next problem. And I think, is this the only one I'm going to ask you to do? We may or may not do this. All right, so example 3 asks you to solve the triangle. If they ask you to solve the triangle, then you are going to have to find all the sides and all the angles. All right, so that's what it means when it says solve the triangle. I do not like solve the triangle problems because it means you got to do a lot of work. All right, I especially hate solve the triangle problems that are also ambiguous case problems, and you will see why by the time we are done with example 3. So, they're not terribly difficult, just like. So, do we have to be careful on this one? Yeah. We've got an angle and two sides. The angle is not in between. So, angle, side, side. Watch out. It will be, if it is side, angle, side, the two sides that you know, it will be the angle that forms where they meet. So, it would be this angle right here. Okay, so if it is not, then it's going to be angle side, side.
So there could be two like different, so 70 could be like up.
Right, so if 70 was here or here, you would have angle side, side. If 70 was between these two sides, then we would not have to check. We also would have to use law of cosines because that's going to be a law of cosine problem, and we don't know that yet. So you won't see those today, but that's a good question. So it does, it does kind of like, you can think of going here, angles, side, angle, side, but it has to do with whether or not it's like between those two sides that you know, if it's that hinge point where they meet. In general, for what you're going to see today, if you've only got one angle, it's going to be an angle side, side problem. If you got if you got two angles, then you're safe. Anything else, it's not going to be law of sine, so you probably won't see it today. So, we do have to watch out, but it doesn't change how we set up the initial part of the problem. So, there's only one angle we can find. Which angle is it? C. We can find C because we know the side across from C. We cannot find B yet, but we're going to find it eventually. So we have to use sine of 70 over 25 equals sine of C over 26. Is it okay if you set it up like this? Sine C over 26 equals sine 70 over 25. Is that okay? That's fine. Doesn't matter which comes first. Is it okay if you do this? Just see what you know. Is it okay to do 25 over sine 70 equals 26 over sine C? It is. It's okay to do it that way. I mean, I probably wouldn't. I'd stick with the formula. But just so you know about proportions, it is okay for you to do that. Because when you cross multiply, you still get the same thing. So it is okay to put the signs on the bottom for law of sines. If you ever run across anybody that does it that way, it is mathematically correct, but most things are going to put signs on top there. So 25 sine C is going to equal 26 sine 70. And we need to solve this for C, so the first thing we'll do is divide by 25. Get rid of that 25. So we will get sine C equals 26 sine 70 divided by 25. So 0.97728. And I'm going to go ahead and store that. Well, actually, you don't really have to store it because you could just use the answer key. So you need to do sine inverse. And sine inverse of that answer is going to be 77.763. And even though I'm rounding it, I'm going to keep that value. Now, I know this is definitely angle C. Angle C can be 77.763. But this is the point where we've got to check for ambiguous case. And to do that, we will say C question mark. I'm putting a question mark here because I'm not sure. I'll do 180 minus 77.763 degrees. And if I do, I'm gonna store this as C. And then I'm gonna do 180 minus C. I get 102.237 degrees. Is it okay? Could it be 102.237? It could, right? Because 70 plus 102.237 would still be lower than 180. So what we have here is this is an ambiguous case. So we have two possible answers. This angle C is either 77.763 or 102.237. We do not know which one's actually correct. The only way we would be able to find that is if we were doing this in real life, we would go back and take another measurement. You'd have to find another angle or another side so that you could figure out which one is actually correct. But because we can't actually do that, I'm sure they have us assuming that this is not drawn to scale, because they almost always tell you to not to assume that it's drawn to scale. So, so whenever we look at this, we have two possible answers, which means if they ask you to solve the triangle, you've got to do it twice, which is why I hate these problems, because we actually have to find like one set of answers, then go back and do it again with the other possible answer. So this is always tragic whenever this happens. So C could be 77.763. So right now, I'm going to, or actually, we know for sure it can be. Like that, you don't even have to test for that, right? So right now, I'm going to solve it like C is 77.763. So if I want to find angle B, I would do 180 minus 70 minus 77.763. And I stored this into my calculator. So if I do 180 minus 70 minus C, then it will keep the whole decimal there. So 32.237 degrees. So that would be angle B. There. Then I'm missing side B over here. I need to find side B. And so if I do that, I could do, I've got to do law of sines again to be able to find that. You cannot use Pythagorean theorem. You cannot use regular trig because both of those have to have right angles to do it. So you got to use law of sines. So you'll say sine of 70 over 25. Technically, you can use sine of 77.763 over 26. I avoid using that because it's a rounded value and it's just better if you use those whole number values. And then you got sine of the 32.237 over lowercase b. So I would store this actually as my b also, so that you've got that value. So you will cross multiply b sine 70 equals 25 sine 32.237. You would divide both sides by sine 70. So b is going to equal, we got 25 sine of b divided by sine of 70. We get 14.191. Okay, so what we have here right now is we've got one set of possible answers. So if angle C is 77.763, then angle B has to be 32.237 and side B has to be 14.191. But it is possible, because this is an ambiguous case, that that's not true. It is possible that angle C is actually 102.237 degrees. All right, it is possible that that's the case. So, if I do 180 minus the C I've got now, oops, that gives me this number exactly, full decimal. I'm going to store this as my new C. Store C. Okay, so I basically have to go back through and do this whole thing again, like this is not 77, but rather is 102.237. All right, not terribly difficult, just aggravating that you're having to do it again. So your B this time would be 180 minus 70 minus 102.237. And if we do that here, 180 minus 70 minus C, we get 7.7632. So 7.763 degrees. And then, so that's angle B. So now we know that angle B is 7.763 degrees, or could be, anyway. Now we got to set up law of sines again. You'll notice it's going to be the exact same as you did over here, except for this is going to change to this. So it's going to be sine 70 over 25 equals sine 30, I'm sorry, oops, I'm copying exactly. Sine 7.763 over B. And I'm going to store this as B. If you forget to store something and can't get it stored again, you can use the rounded values. It might be off a little bit. I would try not to, especially on a quiz or a test, but, it's not the end of the world if you use the rounded value there. So we will cross multiply B sine 70 equals 25 sine 7.763. We'll divide by sine 70. and B is going to equal, we'll type this into the calculator, 25 sine B divided by sine 70 is going to give us 3.594. It's possible that that may happen. Did you use like the rounded values, like you typed this whole thing in? Or did you use them rounded to 3 places? 3 places, yeah. It's possible that it can be that close on some. It just depends on your numbers. Okay. Yes. Yes, yeah. And it's one set of answers, so like if C is 102, these have to be the values for B. So I would kind of group it half and half there, yeah. So it's not like C could be 102.237 and then B could be 32.237, right? These 3 go together, these 3 go together. The answer key, that's how it'll group it as well. It'll have like 3 answers together or these other 3 answers together. There will be ambiguous case. It will not ask you for all parts at once, but there will be some ambiguous case. Yes. Mm-hmm.
Okay, I'm confused on like how we know it's ambiguous. Like I know you did the 180 the number, but how does the number tell you?
So if it will work in the triangle, so if it's less than 180 degrees whenever you add it all together, then it is also possible that it's this value right here. So since this was 102 and this was 70, and we put those together, it's still less than 180 degrees. This worked. On the last problem, when we tried to put that 132 right there, I had 120 and 132. You can't have 2 obtuse angles in a triangle. That adds up to way over 180. So that is not going to work. And so if it doesn't work, you can say, hallelujah, it's not the ambiguous case. I just have to work it out like it asked me to, right? It's whenever you get something that will work, that's ambiguous case. It means 2 triangles are actually possible. Both of them could be true with these situations, so you got to work it out twice for those. You can have ambiguous case whether or not they're asking you to solve the triangle. So if they had only asked for angle C, we would just give 2 answers for angle C and stop there. We wouldn't have to do the last part, but they asked us to solve, so we had to find all the sides and angles. We cannot tell which one's correct without being given more information. So like if you were doing this in the real world, like you were out surveying and you got, I got ambiguous case, you would go back to wherever you were surveying, take another measurement because you need to know which one is correct. Or sometimes, like in this particular case, which one looks more correct for my triangle? The 77 looks more correct because this does not look like an obtuse angle. So, like if you were doing this in the real world, you would probably be able to tell, like you know what it looks like in the real world and you, that's not obtuse, this is going to be 77. But they're going to warn you on any picture that they give you that it's not drawn to scale. So you can't assume that this is the correct picture right here. So unless we have another piece of information, we just have to give 2 answers and say it's one of these. I'm not sure which one. Okay? All right, we are going to skip this one because I think you guys will be okay doing that. It is not ambiguous case. Do you even have to check for ambiguous case if you have 2 angles? No. If you have 2 angles, you don't even have to check. You just are going to solve, find all the pieces, right? So I think you guys will be probably fine with that. I want us to look at this one. So this is an application problem. Your homework tonight is just like straight triangle problems that doesn't have application on it for the homework tonight. But I like for us to see where we're going, like where we're going to use this. So I want us to do one of these problems right here. Aspen and Gillian look up at the chimney and find an angle of elevation to the top of the chimney to be 56 degrees. They step back 2 meters and find the angle of elevation from that point to be 54 degrees. How tall is the chimney? So when I used to teach geometry, we used to actually go do this. So the idea is the big chimney out here back behind, going from the, like, band room down to the gym. If you look over there on the left, there's this, like, really, really tall chimney. These are not exact measurements because I didn't actually write them down. This is my estimate. Microwaves. You mean in the lunchroom? I mean, I think we do have some ovens that they put stuff in. They're not microwave ovens. They might look, they're like convection ovens where you put a lot of stuff in it. But they are not wood fired. I think this chimney goes to the boiler system that is what, like, heats the band room auditorium area. I don't think it actually is connected to, like, the heat from the rest of this, but I'm not sure about that. It's a really tall chimney. I feel like it's not current. New buildings typically do not have chimneys like this anywhere around them. So I'm not exactly sure. Now, so I used to, when we were doing trig in geometry, I would have students go down there to measure the chimney. So if you can measure all the way to the base of something, this is a right angle right here, right? The chimney should make a right angle with the ground. However, that particular chimney has a fence around it. Here's my fence. So it is not possible to measure all the way to the base of the chimney, except for one year when Miss Brown used to happen to be down there, and one group talked her into unlocking the gate for them so they could measure all the way to the base of the chimney. But it was not my intent for them to be able to do that because I wanted them to have to do it this way. All right, so if you cannot measure to the base of something, this would happen lots of times. Like, for example, if you want to know how tall the steeple on a church is, if the steeple on the church looks like this, you know, if you got your church building like this, you could figure it out if the steeple is right here, but that's usually not where the steeple is at. The steeple is usually more like offset back here somewhere, right? So you can't measure to where the base, it's not a right angle, right? Or if you're measuring anything where the ground is not level, that's going to be an issue. So you're going to have to do it differently there. So there's lots of cases in real life where you would need to know this, where you couldn't measure to the base of something. If you can measure to the base, it's just regular trig. You don't have to use law of sines and cosines. So what they do here is they find the angle of elevation to the top of the chimney to be 56 degrees. So they stand somewhere over here. They find that angle of elevation to be 56 degrees. Sometimes it will tell you, like, use a device called a clinometer for this. You can make a really primitive clinometer that works fairly well. We used to do that in geometry also. So sometimes they'll tell you, like, how far their instrument is above the ground. If they don't tell you that, assume that's just the angle all the way to the ground. There. So that's 56. And then they step back 2 meters. And they find a new angle of elevation to be 54 degrees. And so we want to know how tall the chimney is. So the side that we're looking for, we want to know this. And I'm going to call that right there H. That's the height of my chimney. Here is the problem. If I look at, let's say, this triangle right here, do I know any of the sides of this triangle? No. If I look at the bigger triangle, do I know any of the sides of that triangle? No. I know this little piece right here is 2, but I don't know the length of this whole side right here. Nor can I find it unless Aileen unlocks the gate for us, right? So what I'm going to have to do is I need to find, I do have a triangle that I know sides of. I do know, if I look here, I do know this skinny triangle right here. You can tell my lines are not very straight. Straighten that out. I do know that triangle. I know an angle right here. I know a side, and there's going to be a way for us to find the other angles, right? So I can find any of the sides of this triangle that I want to find. So if I find either, really it doesn't matter, I can either find this side or this side. Then I could use that with the actual right triangle. Okay, so I'm going to pick this inside side right here. I'm going to call that X. But you could very well use the outside angle or the outside side as well. I'm just choosing this one just because I think it's going to look a little better on my picture if I do. Now, what I'll have to have, I know to set this up, I've got angle 54, so I'll have sine of 54. It is across from X there. So I know I need to use that. The only side I know is 2. The angle across from 2 is this top skinny angle, this little tiny angle right here. How could I find it? I need to know that angle. Any ideas? Okay, these two angles right here make a straight line. So they should add up to 180. So we could do 180 minus 56, which is going to give us 124 right there. So that obtuse angle is 124. Then what would I have to do to find this little tiny angle up here? Good, so if I do 124 plus my 54, I get 178. Subtract that from 180. This angle right here is 2 degrees. You'll find that it is always the difference between those two angles in this particular situation. Okay, so now do I have to worry about ambiguous case? I've got 2 angles. I don't have to worry about ambiguous case when I've got 2 angles. Thank goodness. I know there's going to be one answer here. So I get x sine 2 equals 2 sine 54. I'll divide by sine of 2. And so x is going to equal, we'll use our calculator, 2 sine 54 divided by sine of 2. And we are going to get 46.363. But again, that's meters. I would store it. I don't store it as X. Store it as, I'm going to just call it A here. There. So what I just found is that this side right here is, right here is 46.363 meters. That is not my answer because that's not how tall this is. That's that slanted height. Well, I'm not sure about how well this is drawn to scale. Actually, it's drawn to scale pretty poorly. Our answer is actually going to be a little higher than that, I think. It doesn't look like it on my page, but I think it's going to be higher. Because 56 is bigger than this angle here. No, it'll be shorter, because that's our hypotenuse, right? That's our hypotenuse. So our angle, it's not too bad. This side right here is going to be less than 46.363. All right, so now what I want to do is I've got to do a second triangle. I am just going to look at this right triangle right here. This is a right triangle. I got a right angle right there. So since I have a right triangle, I can use just regular trig, or you can use law of sines. Law of sines still works, right? But regular trig, I know this angle right here is 56. This is opposite. This is hypotenuse. So opposite and hypotenuse, which one would I use? Sine. I would say sine of 56 is going to equal opposite, which is h, over hypotenuse, which is the 46.363 that I just got there. So I will multiply both sides by that 46.363. And if I take that answer and multiply it by sine of 56, I will get 38.463. So 436, and that's meters. And that is my height. That is my answer. There. Okay, trig, super useful in like surveying sort of context. Here, finding the height of something because you're not climbing up to the top of that chimney and using a tape measure to measure it very easily. Okay, so for this, you're going to cross multiply. You will get sine of b times 25, so 25 out front, 25 sine b equals 33 sine of 136. And you will divide by 25. So I got sine of b equals 33 sine 136 divided by 25 is going to give us point. Hold on. Did I type that in right?
Yeah,
Am I in?
got
That's what I got.
We're going to get an answer. Okay. We're going to do the inverse sine of that answer. Okay, so B, you're in radian mode, I bet, if you're getting negatives. 66.484. Okay, this is different than I was expecting it to happen. So, look at your problem. Is that possible?
No, because
That adds up to more than 180 degrees, right? But this is your first answer, right? So, the other one, the 180 minus 66.484, it's not going to be any better. It's going to be a bigger number, right? So, this one's not a triangle. Okay? Now, normally, let me tell you, because there's another one that this happens on. Normally, it doesn't happen this way. That's why I was a little bit puzzled. Normally, what happens is you end up with something like this. Sine of B equals 1.213. If you try to do sine inverse of 1.123, you're going to get an error. Can sine ever be bigger than 1? It's got to be smaller than 1, so that is usually what happens when it's not a triangle. So if you get an error there, it's also not a triangle problem. It's going to be 11, I think. 11.
How do we, I don't have a calculator.
Oh, I have been using the calculator. Desmos will do all of this.
Okay.
Good question. Thank you for asking. Extra thank you. Desmos will do all of this. It's in the menu, so you can use Desmos for this at home. In fact, I don't guess there's any reason why I can't let you use Desmos on the quiz, like quiz and test as well. It doesn't give you like a super big advantage.